Hey guys, so today we're going to be talking about central angles of circles and arcs. And these might be some new words for us. So first of all, let's talk about a central angle. A central angle, so this is a central angle, and this is circle O. It's labeled O. A central angle is an angle whose vertex is the center of the circle. So you can see that this angle has two rays that are its sides. In this case, it's the segments AB and AO and OB, and they create this angle called the central angle. Now, the outside of the circle where they hit, so from here all the way across to here, is called an arc. So we would call that an arc of the circle. And there's two types of arcs that we're going to be talking about. We're going to be talking about a minor arc, which is part of a circle that measures less than 180. So minor arcs are 180 degrees or less. And a major arc is between 180 degrees and 360 degrees. So it's between 180 and 360. All right, well, a minor arc, how do we tell them apart? Well, a minor arc, we use two letters. So we would take the endpoints of the arc, so A and B, and we have another symbol that we're going to throw in here now. So this symbol, it looks like an arc. It's like a little half moon on top of them. So it's not a segment symbol, so be careful there, okay? And then a major arc, if I took this picture and I put a C right here, we would start, again, we'd pick the endpoints of the arc, but instead of going A towards B, we'd go from A to C and then all the way back around to B. We'd use three letters, A, C, B. Okay. So you can tell the difference usually by the number of letters, and we need to make sure that we realize that that arc would be all the way over here. Now, the one thing I need you to understand, though, is that arcs have measure. That means that they are in degrees. They are not a part of the circumference of a circle, so we're not measuring the length. That's called arc length. When we're talking about arc measure, we're talking about an angle in degrees. All right, so for example, this is a central angle. It is 60 degrees. And a central angle is equal to the measure of the arc. And we actually say the measure of the intercepted arc. And that means that we're intercepting the arc here at A and here at B. And so the measure of the central angle is 60 because the measure of this arc is 60 degrees. Central angles are usually pretty easy for students to see, okay? All right. Well, we have another type of angle that we're going to talk about, and this one's called an inscribed angle. Now, we've talked about figures being inscribed in circles. An inscribed angle is an angle whose vertex is on the circle and whose sides contain chords of the circle. So this right here is an inscribed angle because its vertex is right on the circle. It's different than the central angle, though, okay? All right, and again, this is an arc, the intercepted arc, and it's the arc that lies in the interior of the inscribed angle. And something that we need to know about inscribed angles is that the inscribed angle is equal to 1/2 of the measure of the arc of its intercepted arc. It's 1/2 of the intercepted arc. All right, so I think I gave you a picture and it looks like this. I'm sorry, I'm having to draw it. Not the best circle. And here's the center of the circle. I put a dot like that. And it kind of looks like an arrowhead. C, A, B, and D. Okay, so we have lots of things going on here. Okay, so this angle D, its vertex is right on the circle, so this is an inscribed angle. This angle right here is a central angle. So if I tell you that the arc is 50 degrees, okay, so AB, arc AB, the measure of arc AB equals 50 degrees, well then angle ACB, because it's a central angle, will also be 50 degrees, but angle ADB, the inscribed angle, would be 25 degrees. And that's called the inscribed angle theorem. The inscribed angle theorem says that its measure is half of the intercepted arc. All right, so just a couple more things I want to talk about with inscribed angles. There's lots of inscribed angles that you have to kind of be careful for. There's one that, kind of has one of its rays goes through the center of the circle. As long as the vertex is on the circle, it's inscribed. So this is an inscribed angle. This one right here, it's an inscribed angle. I know it looks a little bit bigger. And here is the arc that it actually intercepts. This one, it's above the center of the circle, still an inscribed angle. Its vertex is on the circle. Here is the intercepted arc. Almost looks like the crust of a pizza. And here's one that's really funny. I love this one. This one, I'm going to draw the circle. So here's a circle. This one can be tricky. If I take is when you have a secant and a tangent. So you can see that the vertex of this angle is right here on the circle. But sometimes it can be really, really hard to see. So right here, this is the inscribed angle. Now, a couple things I want to show you. So what if I tell you that this is, I don't know, let's say 100 degrees. Let's say that's 100 degrees. Then we know that the inscribed angle would be 50 because of the inscribed angle theorem. It is half the arc it intercepts. So it would be half of this arc. All right, and I tell you that this one, I don't know, is 200 degrees. So then this would be 100 degrees. And then I tell you that this one is like, I don't know, 80 degrees. So this would be 40 degrees. Now I can make it a little bit harder because I can say, what if this right here is 100 degrees? But I want to find this angle. Well, because this one, this circle, I know actually that the whole circle has 360 degrees, that this value in the blue would be 360 minus that 100, so 260. And then this would be the inscribed angle, so it would be half of that, so 130. All right, so basically, we need to remember that the inscribed angle is half the arc. All right. Last thing, if that's true, this means that three other things will also be true. These are called the three inscribed angle corollaries, okay? So these corollaries are going to come up a lot in the next couple of days. All right, so the first one says that if two inscribed angles intercept the same arc, then the angles are congruent. So looking at this one, angle A is right here. There's the sides of angle A. If I go to the ends of the circle, this is the arc it intercepts. And then if I look at angle B, and I highlight the sides, oops, like that, it also intercepts that arc. So if I tell you that that arc is 50 degrees, well then this would be 25, and this would be 25. So angle A and angle B would be congruent. All right, corollary 2. An angle inscribed in a semicircle is a right angle. So a semicircle is half a circle, right? So we know that half a circle is 180 degrees. So this arc is actually 180 degrees. So the ends of this ray right here hit, its intercepted arc is 180, so the inscribed angle would have to be 90, making this a right triangle. We're going to be practicing this in class, so don't panic, okay? All right, last one is, and this one we're going to investigate. We're going to do an investigation on. But if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So A plus C equals 180, and B plus D equals 180. All right, and again, we're going to be investigating that tomorrow. I know we have a lot going on right here, guys, and it was a lot of information. So let's just recap. We need to know what a central angle is, and how it relates to the arc. So it equals the measure of the arc. You need to know what an inscribed angle is and how it relates to the arc. And then you need to review the 3 corollaries to the inscribed angle theorem, okay? All right, so that's it for today. Have a great day.